Good morning, students. I'm really happy to meet you all once again, even in this session. So we are going to see another experiment. So before going to that, let me introduce myself. I'm Gnanasaram sir. I'm handling you Electronic Circuits 1 lab component. The theory will be handled by Ranjit sir, so I'm handling you the lab alone. So right. So we have almost seen 6 experiments so far. So we have in the sequence, and we have another interesting title today. So today's experiment is experiment number 9. We are going to see about differential amplifier. So why it is experiment number 9? So in the mid, we have skipped 2 experiments, which is based on MOSFET. So any of because I want you to have a continuity. So first we are seeing all the bipolar junction transistor experiments, and then we'll be going into that. So today we are going to analyze the performance of differential amplifier. So first question is, what is differential amplifier? Right. So difference mathematically means it's like subtraction, or the thing which differs from the other thing, right? So that's what I have told shown you here. So difference means the unique out of a crowd, right? And the antonym for is a common. So common means it's a thing which is seen, or which replicates something similar to that. So differential amplifier is a kind of amplifier. Means amplifier means a signal booster. So this kind of differential amplifier is going to specifically amplify the difference between two input signals. So that's what we are going to verify practically, whether it is going to amplify the difference between two signals, and it has to reject the common signal. See, the aim is the amplifier has to amplify the difference between two input signals, and it should reject the common signal. So in practice, for example, if you see what is this application, even in your cell phones, you can see this application. For example, in the higher order cell phones, like above 13 to 15,000, you can see that there is an option in the cell phone like background noise rejection. For example, I have shown you here noise cancellation. There'll be an option in your Android phone. So what it will be is the cell phone will have two microphones. So one is to pick your audio, which you speak. The other is to means pick up the surrounding signals, right? So the surrounding signals comes to this mic as well as this mic. So which is the common signal or the noise signal. Without making any partiality, it enters every line. So that common signal, that is the noise signal, to be removed, and the signal, uh, the actual signal which has the content, is to be amplified. So the actual signal, whatever we speak, goes to this mic and not this mic, right? So that's the different signal. So that's the classical example for differential amplifier. So the agenda is to amplify the difference between two input signal, and it has to reject the common signal, or means common signal means it's the noise signal. So that's the thing. So in today's experiment, the agenda is we need to measure. We'll be giving an input signal just for checking purposes. The frequency is not important and the amplitude is what important. So we'll keep the input signal and we'll see the output voltage for two kinds of circuits. So one is for differential mode, the other one is for common mode, and we'll try to take differential gain and common gain, out of which finally we'll try to calculate common mode rejection ratio. So if you see what is differential gain, it is the ability of the amplifier to amplify the difference between two signals or two input signals. Common gain means it is the ability of the amplifier to amplify the signal which is common to both signal lines. And common mode rejection ratio is the ability of the amplifier to reject the common signal and to amplify the different signal. So this single parameter is going to speak what is the quality of the differential amplifier. Means the CMRR is very, very important as far as differential amplifier is concerned, right? So let's not go too deeper into theory. So today's experiment, these are all the components and equipments required. So we need BC 107 or 547, two numbers, and resistors we need 10 kilo ohms, two numbers, and 4.7 kilo ohms, one number. Other than that, we need breadboard wires, CRO probes, etc. So equipments we need is RPS. Regulator means regulator power supply. We need dual power supply, and we need a CRO and a function generator. CRO to view and function generator to generate a signal, right? So this is the circuit diagram for today. So we have two circuits to verify. So the first circuit is in the differential mode. See, you have two transistors. It's in common emitter configuration, means you take the output at the collector. So in this differential mode, you'll try to give input to one of the transistor. The other transistor is kept at reference or ground potential, means 0 volt. In certain circuits in books, they would have given another V in and they would have checked, no issues. This is also it's not a problem. So here, one transistor we are giving the signal, another transistor we are having 0 voltage. So both the bases is at different potential. So right, so the difference between these two should be amplified, means a voltage and a zero to be amplified, and you need to get it right. And in common mode, you can see that the same signal is being given to both the transistor base, right? So that's, so it's almost like mimicking the noise signal which enters this transistor and this transistor, right? And we'll see what is the output. So the gain of this mode, the amplitude output voltage should be high, whereas here it should be low. We need to verify how it works, right? So the procedure is very simple. So as usual, we need to give the connections as per the circuit diagram. We need to set the input voltage constant, right, for both the modes. So for one mode, we'll keep one input voltage. For another mode, maybe a different input voltage. So it depends. And then we need to note down the output voltage for differential mode as well as common mode, right? So finally, we need to tabulate it. We have 3 tabulations today, and we'll try to calculate common mode rejection ratio, because that's a parameter that indicates the quality of the differential amplifier. So this is tabulation 1. So to find out a differential gain. So we'll also compare the practical and theoretical value. Theoretical value has been calculated in the manual, which will be circulated to me, right? So we'll have input voltage and output voltage for differential mode, and we'll calculate V naught by Vi is practical differential gain. Got it? And the tabulation 2 is for common mode, obtaining common mode gain. So like previous one, we have input voltage, output voltage, and the practical value of common mode gain is V naught by Vi. So that is AC. And tabulation 3 is to find out CMRR. So we have a common mode gain and we have a differential mode gain from the previous tabulations. So from there, you'll try to calculate CMRR, common mode rejection ratio, right? So common mode rejection ratio is AD by AC. If needed, we'll go for the decibel scale 20 log AD by AC. So that's the value for CMR. So we'll have a practical value and we'll have a theoretical value also, right? So that's all for today. So now, sorry, that's all for this first half. Now we are going to do the experiment and we'll check how it's going. So students, are you ready? Let's go and check out how this amplifier really works, right? So what you see here is the connected circuit. So as usual, you have a function generator to generate the input signal, right? So I've kept some 3 kilohertz here. Frequency response is not, we are going to find it out. So we'll be finding the gain, right? Common mode gain and differential mode gain, right? So we have a dual power supply. So to give VCC and V minus V, so we need dual power supply. So we have a CRO here to view the output, right? So, and this is the circuit, whatever you see. See, there are 2 transistors, collector, and the collector 10 kilo ohms is given, 2 emitters. See, I've connected one transistor in this way, another transistor in this way. CBE, both emitters are shorted, and it's going to ground, right? So no, not ground, sorry, minus V. So this is going to minus V minus terminal, right? And 2 collectors has a collector resistance going to VCC. The input, so right now I have connected in a differential mode. How do I say differential mode? The base of the second transistor is being grounded. The base of the first transistor is being given a signal from function generator, right? So this is a differential mode. So I'll try to keep 0.2 volt, right? And at the output, if you see how much voltage I'm getting, so it's around, for example,
Let me show it to you. Let me adjust it properly. So it is 1, 2, 2.2 into volt per division is not 1. You see, volt per division is 5 here. So it is 11 volt. So that's what I've written. So input voltage is 0.2. Output voltage is 11 volt. So this is for differential mode, right? So, and if you try to put 11 divided by 0.2, you get a value of 55 in your calculator. The theoretical value is 265. It will be there in your manual. So there will be formulas about how to calculate. Got it? So this is differential mode. Now let's go for common mode. So in common mode, the base of the second transistor, which is grounded, need to be shorted to the base of the first transistor. I mean, same signal should go to both the transistors, right? You almost get small, very minute signal. So what I'm trying to do is I'll try to improve the input signal. So I'll try to keep 2 volt at the input. Okay. So now I have 2 volt at the input. We'll try to see what is the output voltage. You see. So I'm almost let me adjust it for you. See, I'm almost getting 1.2 and 1.4, right? So let me note it down. So 2 volt is the input voltage and output voltage is 1.4. So 1.4 divided by 2 is, means V0 divided by V in is 0.7. So theoretically it has to be 1.2. So our amplifier is rejecting the common signal better. So it is only 0.7. But you see the differential gain, it should be around 265, but ours is having 55. It's far better, not as exact we expected. Any of. So the next one is common mode rejection ratio. So there's nothing to take it, only to tabulate. So this 55 comes here for differential mode gain, and this common mode gain comes here for common mode gain, and CMRR is nothing but 20 log AD by AC. So when you put 20 log 55 by 0.7, you get a value of 37.8, whereas the theoretical value should be 46. So we get around the same range. So instead of 46, you get around 37. So only the difference is 9 dB. There's a difference. That's not a major difference, right? So that's it for today. So this differential amplifier will try to amplify the difference between two signals, so that we have demonstrated it, right? That's how it really works, right? So meet you all. You can contact me. There's a WhatsApp number in the link. And if you want to appreciate it, you can very well put it on the comment. Subscribe the channel to get the videos continuously, right? So see you all with another experiment. Thanks for watching it.